This question is about the modulus function. So to sketch the graph of the absolute value of a linear function, just start by drawing the line. So the line y equals to x plus 1, the gradient is 2, the y-intercept is 1, so this y-intercept is 1. To find the x-intercept must be something comma 0, so the y must be 0. You solve for x, and you get x equals minus 1/2. Right, so to draw the absolute value graph, you flip this negative part upside down, forming a V-shaped function like this. So you have to make sure the shape is a V and label the y-intercept, x-intercept. Solve the inequality. So we're doing it algebraically here. The first step is to treat the inequality, treat it as an equation. So you replace the inequality sign with equal sign, and now absolute value means we have two possibilities, plus or minus. If it's plus, 2x plus 1. If it's minus, minus 2x minus 1. And then we solve. We get x equals minus 4. We solve this, so add 2x to both sides and subtract 5 from both sides, divide by 5, we get x. So after you solve the two equations here, you have to plug in to the original equation, because it is possible that we have to reject one or both solutions. So using this equation, we replace the x with minus 4, we replace this x with minus 4. Make sure you use the absolute value, the ABS button in the calculator to use this absolute value function. And if you check with the calculator, you get minus, plus, they're not the same, so this is rejected. We cannot use this solution. And if you plug in minus 6/5, now you get something exactly the same, which means we can use this solution, which means we have only one critical value. So we put this critical value on a number line. So you draw a number line with the minus 6/5. So since we have only one critical value, we have two intervals to check. So the answer can be smaller than or bigger than this critical value. To check which interval we can use, we use the original inequality. So it's an inequality, and we use the absolute value. So we can plug in any random number in this interval. So in this interval, we can use something smaller than minus 6/5, such as minus 10. So you replace the x and this x with minus 10. Use a calculator. If you get something smaller on the left, then we use that interval. So since minus 25 is smaller than 19, it agrees with this inequality. We have this solution here. And if you check using something random on the right side, something bigger than minus 6/5, such as 10, you plug into the inequality, you get 35 is smaller than 21, which doesn't make sense, which means we cannot use this interval. So the answer is therefore smaller than minus 6/5. Alright, I'll see you again next time.